I believe we are live. Quickly check. Yep, we are actually live. Okay, so hello everyone. I'm Andrea Angela, and today we are looking at a paper from October-November 2016 on problem solving and programming skills for the A2 level computing. Okay, so let's have a look at the paper. Okay, so the first question is basically all about writing some code, and I'm gonna use Python as the language, as the primary language. So we have a user basically that can use. We have a system that is a safety deposit box, and the user can actually use a 4-digit code in order to actually lock and unlock this deposit box. There's a keypad. You can press the numbers or the reset button or the enter button, and the whole idea is fairly similar to what you might find in a gym to actually lock your belonging. So you have you need to open the deposit box in order to set a code. You enter 4-digit code number, pressing the numerical keys, and then you press enter. Okay, and until the user actually clears the code, it will be the same for the deposit box. Then the user can close the door, and then the user can set the code in order to lock the door. And also, to unlock the door, the user needs to enter the set code, and the door will automatically open, and the user can also clear the code when the actual door is open. Okay, all of this is clearly explained in a table that describe the transition from one state to another. So you have the current state, the door is open and no code is set, the event that occurs, like 4-digit code entered, and the next state. So this is a system that is perfectly described using a state machine. And exactly the first question is actually filling the details here in order to describe the state transition diagram, how the system state change based on the user input. So the first exercise is mostly about basically reading the initial table that's been given to you and basically create a diagram out of it. So at the beginning, as you can see, we start from the state door open, no code set. So the circle actually represents a state of the system. So there is only one possible way to move out of the door open, no code set state. And as you can see from the table, there's only one element in here in the current state, that is door open, no code set. And when the event 4-digit code is entered, the next state is the door is open, but the code is set. Okay, so that's what we want to do first. We want to in here we want to specify the event that occurs. So in this case, it's the 4-digit code entered. So when this 4-digit code is entered, we move from this state to the end state, that is door open, code set. Door open. Okay, so the arrow between state is actually represent an event, and then the circles represent states of the system. Then, when you are in the door open code set state, as you can see, there are two possible situations where we are, two possible things that we can, two possible events that can occur. The first one is when R is entered. So we move to door open, no code set, and the other one is when we close the door, then we actually we go to the door closed state. So let's have a look here. So we have this moving to door closed, and this state moving to door open, no code set. So you can see in the table that in order to move to door open, no code set, you need to enter R, and then here you can put R entered. And the other event instead is closing the door. So if the door is open and the code is set, and you close the door, you go to the door closed state. Okay, so now if you are in the door closed state, the only way to open the door, what would it be? To actually not lock the door, is to set code entered, because you need to lock the door first. So you can see when the door is closed, and you enter the code correctly, the door becomes locked. And you can see, so this one is going to be door locked. And this one is going to be, as you can see from the table, the set code entered. Okay, then we have 2 extra events that we need to fill out. So when a door is locked and you press reset, you stay in the door locked state. So no matter how many times you do this, you will always stay in this state. And if we are in the door locked, in order to go to the to actually being able to unlock it, what do you need to do? You need to actually set code entered. You need to actually enter the correct code. Okay, so this is actually the diagram that describes the system. Now we're going to write some code that actually represent this system. So the first question is, so we have we want to do this using object-oriented programming, and Python allows you to do object-oriented programming, so to create classes. So we have a class called safety deposit box that contains 2 fields: the code, that is the 4-digit numbers represented as a string, and a state that is also a string that allows you to set 4 different states: open no code, open code set, closed, and locked. And then there are 5 methods: the constructor, create, that allows you to actually initialize the object; reset, that clears the code; set state, that actually set the state; and set new code, that set the code; and a method, state change, that will actually implement the algorithms that that is described in the diagram. So I'm going to use Python, right? And I strongly recommend you to get familiar with Python using an actual IDE. Also, during the exam, you actually have to write Python yourself on paper, so you need to make sure that you understand the syntax of the language. But if you are still in the process of learning how to code, the best way to do it is using an IDE, is to actually write proper code using an editor, so that you can run it and actually do a syntax checking and verify that actually works. So let's move to the IDE and actually answer the question in the IDE. So I have PyCharm Community Edition. That is a free version of an IDE for Python. It allows you actually to write Python and run it. This is I'm using Python 3. Okay, so I already done the exercise, but I'm going to start from scratch. So the first question is to describe the create method. The create method is actually the initialization of the class. Obviously, in order to be able to run it, then we need to define the class. So this is not strictly asked, but we need to do this. Let's say we want to create a class, safety deposit box, all right, in Python. And here we can actually do the answer for the first exercise, that is B and I. Okay, so let's do this. This is a way to actually do a comment in Python using the hash. Okay, so let's do the each constructor. The way to do constructors in Python is using init, def __ init. So I have auto completion, as you can see, and self. And self actually is basically a way, as a reference to the object itself. You always need to use self in order to access members of the class. What actually the initialization need to do, as described here, the method to create and initialize an object. What we need to initialize, we have 2 possible fields. One is code and one is state. So we want to actually set those fields, code and state. So we do self dot, let's start from code. The code, let's say we don't really know. So let's set it to an empty string, right? And then we have state, and let me set it to open no code. So at the beginning, open no code, the actual deposit box will be open and no code will be set, so the code will be empty. And this is basically it. An important things, I used underscore here, and this is a way to basically say that this field is actually private. so that should not be accessible outside, even if in reality Python doesn't really provide any way to, you know, it doesn't stop you to actually use those, but it's a convention to use underscore to make sure that you are not using it. So, for example, if I do, let me try to run this code, and let me try to create a box, and I do a safety box like that. Now I could actually print the box underscore code, and I could print the box underscore state, just to see. And using the obviously the editor is telling me that I'm accessing a protected member of the class, even if obviously I can run this using Control F9. And on the right hand side, you can see that actually I'm printing empty and open no code. All right. So you can actually accessing them, but this is the convention in Python to do this. So we can actually test the code. Okay, excellent. So this is actually the answer for the first question. So we actually, we actually have a way to initialize the object. Next question is the reset method. The reset method, as you can see from the description, is about all clearing code. So we just need to set code back to an empty string. Let's say reset self, and then I want to set code back to an empty string. Sorry, do self, and there we go. So this is actually the answer for the question B2. Okay. Next, we have the set state, and then we have set new code. Okay. So set state it basically allows you to set a state, but in addition to that, you also need to output the new state on the console. So let's do that. So this is the third question. Okay, I have the method set state. It takes self and also takes a state. So automatically is able to detect that I also need a parameter. So I want to set the state. So I'm going to set state. State equals state. I haven't finished because now I have to print it. So let me print the state. Excellent. We could test this if we want. For example, let's say I have the box. I do box.setState. Oops, sorry, I didn't want to have set state like that. I just wanted to have this as a normal method. We call set state, and then let me pass like locked, for example, right? And then I could actually print. These are a way in Python to actually define. Let me actually add an implementation of the string method. This string method that allows us basically to do print box and actually have a nice representation of the box. So this is not been asked in the paper, but it's very useful for when you want to play. So it's always good to define the str method so that you can print basically a representation of the class that helps you to debug the code. Let's say I want to print the code and I want to print the state. I'm using the format here method to actually do this. Self.code and self.state. So what I'm actually doing is let me think, is a string doesn't really need to do a print. So this actually should return the string directly. Okay, so that I can do actually print box. So when I do print box, automatically this str method is called that will actually get the representation of the box. So if I run this now, and you can see that actually the status code is not set, but the state is locked. Okay, excellent. Next question is set new code. So set new code obviously is actually setting the code. So let's implement this. This is 4. So we have a function called set new code. Actually take self and also need to take the code. Right. Then I'm going to set the code to the code. Are we done? To the parameter value, and also need to output a message and the code. So we want to have a message. Let's say current code is format self. We can just use code directly. Okay, so now when we actually call set code, let's say here I call set code, set new code, and I pass it, let's say 1, 2, 3, 4, and I run this. You see that, okay, I set the state to locked. The current code is 1, 2, 3, 4, so we actually set the code, and then when I print the box, you get 1, 2, 3, 4, and the state is locked. Okay. Okay. It doesn't like that. I have an empty line there. Okay, let's see what's the next question. So the next question is do some sort of validation. So because the code is a string and we are only able to accept codes that are 4 digits, we want to be able to validate the input of the user. So in order to validate that, we need to have a function that returns true if the string is actually correct, is valid, otherwise false. Let's do that. So we have one function. So this is actually exercise P5. And the function is, it's going to be private. So let me use underscore here to say that this function won't be accessible externally. Obviously, the visibility will be, you can adjust the visibility, like you might don't want to expose other methods like set new call, set state, for example, but for the purpose of the exam, it's okay. So let's define this function, def valid, and we take a string s, and we want to validate that. So what we want is that the length of the string is 4, and each character in the string is a digit. Okay, so we can do the isDigit check if a string is made of only of digits very easily in Python using the Python function isDigit, like that. And in addition to that, we also need to check the length. And we can use the length function here to check the length of the string is actually 4. And this is actually the function that validated. So we can actually do some testing. Let's try to in there, and let's try to do box dot underscore validate, and let me say I pass 1, 2, 3, 4. This should be valid, is it? So let me print the result of this and see what happened. 1, 2, 3, 4 is valid, right? I don't really want to print box. So perfect. So let's try to test if the length actually works correctly. Let's say 1, 2, 3, 4, 5. They are all digits, but the length is incorrect, and we get false. So this works. And let's say if I want to have let's say 1, 2, 3, 4, but instead of 4 I'm using like A. So that's obviously not correct. If I run it, I get false. Okay, only the first one is correct because there are four characters and they are all digits. Okay, excellent. So this is actually the answer to the question. Okay, so the next question is a bit more tricky. It's you have a very convoluted flowchart that describes the program code for the state change method. So this is actually a method that simulates basically the person, the user actually adding inputting the code and actually changing the state of the machine of the system based on the input. Okay. So what you are asked to do is to actually write the code. So to take this flowchart and transcribe this into code, and it's quite convoluted, but it's fairly simple. You need to just translate the diagram into code. So let's start from creating the function. This exercise is B6. So let me create a function that is called state change. All right, self is automatically added. Okay, first of all, we need to get the input from the user, input chars. So I'm going to get chars equals. It's very important to use the actual property and methods of the original class definition. Okay, to do this. So, and I'm trying to use the same variable names that are actually mentioned in the diagram. So chars equals input is the Python way to actually get a string entered by the user. Let's say I want to enter the code. Okay, so this will ask me for a code, and then we'll save the result into chars. So next, well, we need to check if chars is R. Okay, if it's R, we need to also check that the state is open code set, and if that's true, we call reset. Let's try to do the first line here. So if chars equals R, okay, but also if self.state equals open code set, in this case, we want to call reset. We call reset. We also want to call set state to open no code. So let's call that self.set state to open no code. Okay, so we've done the first line, but there is a no here. So if the state is not open code set, we just go. We don't do nothing. We just go down, and we just go to the end of the method. So we don't do nothing if it's false. So that means that all the rest of the logic should be in the else if. That's elif in Python. So elif. So if chars is not R, what we need to do? We need to check if chars is code. Okay. So let me check that. If I like to add an empty line there. If chars is code, right? Then if it's code and is locked, is state is locked. What we need to do if it's locked? We need to call set state to open code set. Set state. So it's really mechanical translation. So you don't need to understand what actually the code does at this point. You just need to mechanically translate the diagram into code. And this, so if it's locked, this is set to open code set. While if it's not locked, you need to also check that if the state is closed, right? So if you need to do another elif self.state equals closed. If it's closed instead, what do you need to do? If it's closed, you need to set the state to locked. Set state to locked. Excellent. Alternatively, you need to just carry on and do nothing. Right. So if the chars is not the code, we need to check if the chars is empty and the state is open code set. That means we are actually closing the door of the safety box. So let's do that. Elif. So the next step is if chars is empty, and we need to actually wrap this into parentheses to avoid confusion to the interpreter, and state is open code set. All right. In this case, what we want to do, set the state to close. So it's very hard. Try not to think about what the code does while you are translating. You really need to stop not thinking about the logic. You need to just make sure you actually copy the code as it is described in the flowchart. Next, if the state is not open no code, you just need to output error does not match set code. So this means that so we are here. We set the state to closed. If that's false, sorry, I miss a step. So we are here. We are here. So I called the close. So we need to check if this is valid here. If self dot is valid, and we pass the chars. So if it's valid, what we need to do? If it's valid and the state is open no code, if self.state equals open no oops, not code. What happened? We need to self.set new code to actually chars. So chars is the new code because and else also we need to set the state to open code set. Self set state to open code set. If not, we need to do the output. This is just a normal else because there is no condition associated with it. So we can just do a print of error code. Then if the previous if is a no, we need to error code format incorrect. So we need to just go one indentation like that, and then do print, oops, too many indentation, print of another error. In this case is basically the validation failed. Not valid, we say the code format is incorrect. And then we end the method. So this is actually the whole method that is the representation of the flowchart using code. Okay, so what's next? We want to test this. We want to test this code and see if it actually works. So we're going to test it now with the next question. The next question is actually asking to write a program that simulates the safety deposit box system. What actually does is create a safety box and then loop forever calling state change. Okay, so let's implement this code. So question still B 7. We want to define a main method basically that create. No, we don't want self. It's just a main method. It's the main. We don't want this to be as part of the class. So okay. So this is our class, right? So I can collapse this, and then I want to define a main method outside it, right? That contains our initialization. So the instance is called this safe. So let's call it like the paper. So this safe. So I create a safety box called this safe, and then I need to actually loop forever. How can you loop forever? You can just do a while true, and until that's forever. I call this safe dot state change. So this basically is calling state change forever after the box has been created. So now we need to call main. So there is a way of doing this in Python fairly easily. You can just do call main like that if you want. So this should be enough for our purposes. But the right way of doing it in Python should be to check if name equals let's call main to avoid that we actually run the code if it's not the actual main, something like that. So now I'm gonna run this and see what happens. So I've been asked to enter the code. So let's say I press 1, 2, 3, 4, and then I get the current code is 1, 2, 3, 4, and the state is open code set. So the code is set. The box is still open. Now I want to actually close it. If I press enter without putting anything in there, is actually closing the door, because that's actually how the logic works. If you pressed an empty chars right here and the state is open, then we get to close, and that's basically what happened. So we tested these bits here, and we tested the bit actually the set code. That is basically this one. So we enter 1, 2, 3, 4 is valid. So the state was open no code because it's the initial state, and we set the new code to 1, 2, 3, 4, and then we changed to open code set. Okay, so we tested this part of the code and we tested this part of the code. So if I now enter the code again, 1, 2, 3, 4, that is the correct one, I'm gonna actually lock it. What we tested here is we enter the code again, that is the same as the set code, and we were in the closed status, and now we are in locked. So now the box is locked. What happened if I type the same code once again, we know that this will unlock the box, and that's actually what happened. The state is now moved to open code set. So we tested this bit as well. So we typed the code again, that is the same, the set code, and now we were in the locked state, and we actually unlocked the box. So we tested all of these things here for now. Then now I am in the open code set. So if I press R, what happened? Actually, testing this is R. I am in the open code set, and I do a reset. So there's no code anymore, and I get back, and I basically get back to open no code. So I don't have any code set, right? Let me try to enter an invalid piece of code, and then I get code format incorrect. So we tested this. Okay. Let me try to now re-enter another code. Let's say I do 1111. Right now, I am I am in the open code set state. Okay, I need to close the box. So I'm in the closed box. But if I try to now set another one, 2222, I get the error. The does not match the set code. There's no match of the set code because obviously I'm trying to lock it, but using a code that is not the one that I actually set when the safety box was open. So obviously it's print the error. So actually we tested that this code works. We tested all the possible branches of the execution. It's pretty nice. So we can actually terminate the program here. Okay, so you obviously don't have the ability to do this when you are at the exam, but you need to try to do this on your mind if you want. If it makes sense to verify that it actually works, but it's not really needed. The exam only requires you to actually translate the code. Okay. Then next. Okay, so now we kind of finished with the code. So the next question is, all right, let's say we have this safety box, and we made the code and the state private, the create and the state change method public, and the reset, set state, and set new code private. So why? Describe what's the effect of declaring the safety deposit box properties as private. So one of the key things about object-oriented programming, when you define a class, you should try to encapsulate as much data and behavior as possible, so that you only expose the relevant information to the outside world. So this helps to make the class more consistent, so that you do not easily allow the user of your class to mess up with internal details. So this is actually called encapsulation. So, and the effect is that the properties can only be accessed inside the class. So the class is the only piece of code that is able to set code and state directly. So no other code externally of the class is able to actually access this information. And that's very good, because the safety deposit box is responsible for setting this information. So I would write this down as like that. So the properties can only be accessed inside the class, right? And I would say that so this provides encapsulation and helps to maintain the object, to maintain the object, in a consistent state. Because if the class is the only one that is able to actually change code and state, it's not possible, for example, to set state to a random string. That doesn't make any sense. You know that you can only have 4 states, and only the class will be responsible for maintaining the object in a consistent state. So the next question is, describe the effects of declaring the 2 methods of the class as public and the other 3 as private. So as the same as properties. So the fact that we declare them as private means that they can only be called inside the class, while the public methods can be accessed by anyone. So that's basically the effect. So private methods can only be called inside the class, while public methods are accessible by anyone outside the class. Yeah, anyone. Okay, so the next question is about the editor. So circle the programming language that you have studied. So I'm using Python, so I'm going to circle Python. What's the environment that you've used? We have used to learn it PyCharm, for example. So list the 3 features that the editor has that help you to write the program code. So if you get back to the editor, you can see that what we actually use is syntax coloring. You can see that like class and def, that are keyword of the language, are colored in orange, and the name of the methods is yellow. So this is really useful for you to understand the various part of the program. If it was all black, it would have been quite difficult. Another useful thing is auto-completion, like when you do self dot, you can see the list of methods and properties. It's extremely useful. You can collapse definition here, so that you don't need to use all. You can save some space and help readability. And you also have automatic indenting. If I press enter here, automatically, the code is aligned with the initial of the previous line of code. So this is fairly useful when you actually code. So let's pick 3 of these. Let's say keywords coloring is 1. Let's say we have auto indentation, and let's say we have autocomplete, for example. Okay, so explain when and how your programming environment reports a syntax error. So let's say here I make a syntax error, like, oh, I do not have a semicolon here. What happens if I run it? So you see that there is an error here in the output window. So basically what happens is you do not know that the error occurs until you actually run it. That's usually what happens with the interpreted languages like Python. Despite the editor is smart enough to tell you that there is a syntax error. Okay. Usually, this is basically for Python happen when you actually execute the code. Python program is executed, and how basically shows the error message in the output window. So in the output window, this is called output window. Okay. Next questions. Okay, so we have a piece of code here. We are looking at the Python one. So let's circle A. This is the one we are looking at. So we have been asked to, let's have a look at what we've been asked to. The programming environment reported a syntax error in this binary search code, and state the line number. So I could have actually copied this into the editor, but I actually haven't. But we need to actually spot the error ourselves. So it's very important to do that. So this means that you need to understand the Python syntax to be able to spot the syntax error. So let's say, so we have a def, the name of the method, we have some parameters, that looks fine. We end with semicolon, that's all right. Index equals -1, that's all right. We do a while, we do a condition. Not here, we use a AND keyword, but the keyword AND doesn't exist in Python. You need to use the AND ampersand, like we use it here. See, we are using AND, so that's actually the error. And this is line 3, all right? So the error is in line 3. Let's actually say that. Let's see if also this is the only error. If you carry on, you see that we just do an assignment of the variable, we do an if with semicolon, we set a variable, all the rest looks correct. So the error is in line 3, and to fix it, you basically need to use the AND. So you need to repeat all the line, index equals -1, and instead of using AND word, lower than high, and then semicolon. Okay. Then the next thing is state whether the program written in your programming language are compiled or interpreted. So we already said that Python is actually interpreted. We also actually be compiled, depends like by your environment. You could compile Python down to machine code if you want, but most of the time Python is interpreted. I think both the responses are correct. The next question is asking that there is So a programmer corrects the syntax error and tests the function. It does not perform as expected when the search item is not in the list. So the binary search is a technique that consists of actually finding the index of an element inside an array that is ordered. Well, when you try to search for an item that doesn't exist in the list, something goes wrong. Okay, but we know that the syntax is correct. So this type of error is definitely not a syntax error. It's something different. So let's have a look at the function. Okay. So the idea of the binary search is that you have a list, it is an array. You have low and high, that is the index of the first element that you want to search for, and high is the index of the last element you want to search for, and then you pass the search item. At the beginning, low will be 0, and high will be the length of the list -1, so that you basically want to search across the entire list. So the idea is that because the binary search assumes that the list is ordered, all the elements inside the list are actually ordered. That means that if you try to look at the middle of the list, and the middle is actually identified by high plus low divided by 2. So if the middle element is exactly the search item, fine, we actually found it. But if the middle element, the value of the position at the middle, in the middle element is actually lower than the search item, means that you need to search on the right hand side, so on the right subarray, sublist basically. While if the otherwise you need to search on the other one. So it's basically called binary because at every single step in the way you look in a different direction. So you basically split the search in twos. So what's the problem here? So what we do is we set index to -1. Okay, so basically what we expect is that if the search item doesn't exist in the list, we would like to return an index that is -1, something that is invalid. So the result of the binary search will be an index that points to the element that we found. But if we don't find any element, a common pattern is to return -1. Let's see if actually this is the case. So if until index is -1 and low is less than high, so that we actually finish the search, we carry on. So when we actually find the search item here, we set the index with the middle, okay? And then we also return middle. But this index is middle is actually set only if let me see. So in middle is so we actually return middle here. Is that the right answer? So is the right answer if the item is found, because basically index will be the same as middle. So as you can see here, middle is set to high plus low divided by 2. And if the middle element is actually the search item, index will be also middle, and we return middle, fine. Okay, but if the item is not found, this line here is never called. So the line index equals middle will be never called. So in this case, we will finish the loop, and then we return middle, but middle doesn't exist. So it basically is never set. Or actually, no, actually, it will be set to a value that is not -1. So we actually set to some sort of number, but whatever number we return won't be the right one because we know that the item doesn't exist. So returning middle is not correct. So the correct answer is to return index, and this is actually a logical error because basically when the item doesn't exist, we return an index that points to a value that is not the same as the search item. So it's basically a false positive. We return a false positive. That's not good. It's very bad that the binary search function returns a successful find. That's an element being found when actually it doesn't exist in the search. Also, it's not the purpose of the paper. Assume that you actually know the binary search algorithm. So if you want me to go into a bit more detail about the algorithms itself, feel free to ask me on Slack, and I can actually maybe do a bit of video that explain a bit more in the details how the binary works. But you can easily even if you don't understand the algorithms during the paper, because you've been asked that there is a problem when you actually try to search an item that doesn't exist, you know that you want to return -1. That's basically the assumption here. But you can verify the logic that it will never happen. So the answer here is that this error is it's actually a logical error. So the code compiles, the code actually can run, the syntax is correct, but actually it doesn't work properly. And the line is actually at the 11 at the return point, because we are returning the wrong index. So the line is 11. And the correct things to do is to actually return index. That's the correct things to do instead of middle. Okay, so state the programming environment that is used. I'm using PyCharm. And two debugging features. Okay, so debugging is basically helps the programmer to actually run the code step by step. Let's say one of the key features is actually being able to click on here, like setting a breakpoint. So if I now run the code, for example, obviously I have the invalid code here that I need to fix. All right, now it's working. Let me run it. So I enter the code. I can put the number here. I press enter, and then actually I'm not running as debugging. Sorry, and you need to actually make sure that when you run it using the debugger attached. So I do run it with debugger. Actually, let's say 1, 2, 3, 4. Boom, and then the program stop at the point when you hit a particular line that you want to inspect. And at the point of the inspection, you can actually look at the variables, see what's the status of the code and the state, and you can actually like see the status of the code at the point where you want it. And in addition to that, you can also carry on the code. I think is this, but no, not this one. We need to do tools. Let's see, step over, that is F10. You do F10, you go to the next line, F10, you go to the next line. So you can actually step over and run one line of code at a time, so that you can actually analyze the code and understand it. So these are the two main features of the debugger, in my opinion. So the first one is breakpoint. Breakpoint. That means allows to stop the interpreter at a specific line, so that we can inspect the context of the execution, check if the program works. So it's very useful to understand how a code that you haven't written actually works, or actually to verify more closely if your code works. And the other one is stepping through the code. That means execute one statement at a time to check the effect of it. So you want to verify one statement at a time what actually is the effect on the context of the execution, so that you can verify that actually the program works as you expect. Okay, fantastic. So the next problem is all about assembly, the assembly language. So we have a description of some assembly instructions that match what you actually need to learn for the exam. Immediate addressing, direct addressing, index addressing. You can do immediate addressing using loading the number into the index address, storing the content of a given address, incrementing, decrementing, comparing, and jumping, and printing on the screen, and ending the program. So a programmer is writing a program that outputs a string first in its original order and then in the reverse order. The program uses a location starting at the address name to store the characters in the string. So there are a lot of characters in the name string, and max contains the number of characters that make up the string. Okay, so this code. You don't need to come up with the whole code yourself. Actually, you have a very detailed line by line comment So what you have been asked is actually to ask all of these instructions. Even if you don't really understand the algorithms, how the actual program works, you need to just write the statement for each of these, for each line. Okay, so the first statement is initialize the index register to 0. Okay, the operation to initialize the index register is using LDR, table, LDR, and then you can use 0 as the operand. Okay, so you can check in the table LDR actually load the number into n into ix. Okay, excellent. Then we initialize count to 0. There are two spots here. We need to first load the 0 to the accumulator and then store it. Okay? In order to do that, you need to do an LDM operation, addressing with 0. So now we loaded 0 into the accumulator, and then we store it into count. We set count to 0. Okay, and if you are interested, if you look around here, you see that there is not in this case. Let's carry on. So then we want to load a character from the indexed address name and then output the character to screen. Okay, so in order to do that, we need to do the LDX operation. You can see LDX, given a particular address, we want to load the content at that particular address. So that's basically load the character in position at the address name, and then we output use address name plus the index address. So we do an indexed address, and that's it. Then we increment the index register. We increment ix. It's pretty simple, and then we increment count. Okay, so we need to do 3 statements in order to do increment count. First, we need to load count in memory. Then we need to increment the accumulator, and then we need to store count, similar to what we did before. So we need to do a LDD of count. So this one is a direct addressing. We actually load the value of count into the accumulator. Then we increment the accumulator. And then we store the value of the accumulator into the count location. Okay. Then we need to check if count is equals to max. So in order to do a comparison, you need to do a comparison. You need to do a check. Check that check max count is equal max, because we still have count in memory in the accumulator, so we can compare that with max. And the next step, if it's false, we jump to loop 1. So you need to do a jump if it's negative to loop 1. We just mostly kind of writing down what the command say. Then we decrement the index register. You don't necessarily need to understand how this code works. It's also interesting to learn how that works, but it's not really a requirement to do the paper. So the next step is to set the accumulator to 0 and storing count. So we want to actually set it back to 0. So that's kind of the same that we did here. Initialize count to 0. If you see, set accumulator to 0 and then storing count. This is exactly the same logic. There's some duplication in here. 0, and then we do store count. Then we want to load a character from the indexed address name. That is the exact same stuff we did before. So load the character and then we output it to the screen. Same stuff as here. Load the character and output it. So if you're clever, you can just repeat what you did already. You don't need to reinvent the wheel every time. So you do load name, and then we do out. Then we decrement the index register. We actually get him back, printing the string in the reverse order now. Oops. Why? Ix. Then we want to increment count again, and this is actually the same stuff as here, with just these 3 things. So here we do load count, inc the accumulator, and we storage count. We storage count. Okay. Then now we want to check again with max. All right, it's pretty repetitive. It's a lot of a lot of code to write. It's fairly repetitive and mechanical. And then if it's false, jump to loop 2, same as before. If it's false, jump to loop 2. Then end. That's pretty much it. This is actually the location in memory of count, max, and the actual representation of the string for Fred. Excellent. So finally, the last question is about testing. So distinguish between two types of testing by stating who does what the testing, when the testing occurs, and the specific purpose of each testing. Okay, so acceptance testing is something that the customer of the software does, so the user of the software, in order to verify that actually the software works as expected, so work as based on the requirements that has been given at the time of the software is being commissioned. So the whole goal is actually making sure that the software satisfies the customers and actually does what is intended to do. While integration testing, along with the other kind of testing like unit testing, is all mostly done by the developer. Integration testing is specifically done in order to test the different modules of your code base works together. So you could write individual module in isolation, testing those modules in isolation using unit testing, but then you want to put them together and do some integration testing to making sure that different modules written by different people, different teams actually work together before actually releasing the software. And so that's the whole idea, the whole purpose of integration testing, making sure that when big softwares that are made up of a lot of modules actually works together before shipping to the customer. And it's a good practice to do integration testing fairly frequently, actually as frequent as possible, so that you always are in a state that the software is working. So let's write this down. So acceptance testing is done by the actual user of the software, then and is done when actually the software is being completed. If you use techniques like Agile, for example, where you actually iterate through the development of the software, so you ship the software every so often, like every 2 weeks, every month, the acceptance testing is actually testing what you agreed to deliver in the particular release. So it could be OR iteration as well, for example. The purpose of the acceptance testing is actually to check that the software meets the requirements. So to check the software meet the user requirements. Okay. The integration testing is actually instead done by the developer or the tester. For example, there are some teams that have both testers and devs, or some teams like mine, where I'm working on in Regate, that we only have developers, and developers are also responsible for testing. When we actually do we want to basically test modules together. So when we actually finish writing and test isolated modules has been written and tested, and the goal is mostly to make sure that they work together, to make sure the modules works together as expected. It's mostly done internally by the developers to make sure that the software works. And we actually reach the end of the paper. I'm going to publish this code to GitHub, and I'm gonna send you the link, but it's pretty much on GitHub. Sorry, let me go to GitHub. I'm not logged in. Oh, I need to do the authentication. Oops, I don't have my phone with me. I'm gonna send you the location of the repository on Slack after the meeting ends, so that you can actually download the code and actually try yourself if you want. Fantastic. Thank you very much for watching. And as I said, any question, feel free to write me on Slack or send me an email at angela.andrea@gmail.com. Thank you.